Welcome to lesson 2 for Bellaire High School Algebra 1. This is going to be the first page, part A and B. So to complete this lesson, we need A and B, angles and polygons, lesson 2. Okay, let's start out with talking with lines. Whenever lines exist in space, two things could happen. The lines can go on and on and on like railroad rails and never touch. These are called parallel lines. They never touch each other. Or the lines could intersect, and that creates a series of angles. Notice if the lines intersect like this, we have 4 angles that are created. Okay? Now, let's talk about those angles. Whenever the two lines intersect, one of 3 situations happens. You have 4 right angles, and remember, a right angle is identified with a kind of square, boxy looking shape, and a right angle is equal to 90 degrees, which is what we have right here. 90 degrees in a right angle. Whenever we form a straight angle is actually formed from 2 right angles, like that. Now remember, if a 90-degree angle is a right angle and 2 right angles make up a straight angle, 90 plus 90 is 180 degrees in a straight angle. The final situation we could have is 2 acute and 2 obtuse angles. Obtuse angles are greater than 90 degrees. It's very easy to see that that angle is larger than 90 degrees. And acute is smaller than 90 degrees. It's very easy to see these angles are smaller than 90 degrees. The last item I threw in here that we could study is a circle. Just like a straight angle was formed from 2 right angles, a circle is actually formed from 2 straight angles. Here's the first one, and then here's the second one right here. So 2 times 180, or 180 plus 180, 360 degrees in a circle. Okay, let's go over to the back of the front page. At the top of the page, we have a table that illustrates some different polygons that we might study. 3 sides is a triangle, 4 sides is called a quadrilateral, and so on, all the way down to a shape that we don't know how many sides it has. That's called an n-gon, for n many sides, and that means you could plug in any number here. It's called an n-gon. This could be 30, 50, a million, a trillion, doesn't matter. Plug in any number here. This is how we identify a multi-sided figure that we are not sure of how many sides there are. Let's talk about concave and convex polygons. Now, our first one says a polygon that has a dent or a cave. Well, notice that the word cave shows up in this example, and the word cave shows up in the word concave. So a concave polygon has a dent or a cave. Here's a good example of a 5-sided concave polygon. Or, if we go look at our table up above, a 5-sided figure is called a pentagon. This would be a concave pentagon. That means convex polygons do not have dents or cave. All angles bend towards the outside of the polygon. Here's a good example, the classic rectangle. Now, let's talk about regular polygons. Regular polygons are nice, neat, clean shapes that have everything the same. And let me show you what I mean. Polygons that have all the same side lengths, like squares, are said to be equilateral. Polygons that have all angles the same measure are said to be equiangular. Whenever you put these two properties together, equilateral and equiangular, you get a regular polygon. And you can imagine what those are like. All the sides are the same length. All the angles are the same measure. Okay, let's move on to page 2 for this lesson. So in order to complete this, you will need this sheet that says Lesson 2, C and D, triangles and quadrilaterals. Okay, remember that the three angles in any triangle will add up to 180 degrees. And you might want to circle that, put a couple stars next to it, and maybe even highlight it if you can, because that's pretty important. Okay. Now, before we really start studying and measuring triangles, let's talk about the different classes of triangles. First, we have a right triangle. And a right triangle is identified by its right angle. In this case, the right angle is down here. An acute triangle is a triangle where all of the sides measure less than 90 degrees. So in this triangle, hopefully it's easy to see that all of these angles are less than 90 degrees. An obtuse triangle, however, has one angle that's very large. Something like that. An obtuse triangle has an angle that is larger than 90 degrees. So acute, all angles less than 90. And in an obtuse, one angle let me see if I can get on screen here. There we go. One angle larger than 90 degrees. And in this case, it's this one right here. We have three other kinds of triangles, an isosceles triangle. An isosceles triangle has two matching side lengths. And maybe more importantly than two matching side lengths, it has matching base angle measures. So these sides are the same length and these angles are the same measure. An equilateral triangle is a regular triangle. We talked about this on the other page. All of the sides are the same length and all of the angles measure the same. And finally, a scalene triangle. This is the most random of triangles. None of the sides are the same length and none of the angles have the same measure. So in an isosceles, two matching parts. Equilateral, all three matching parts. Scalene, no matching parts. Okay, before we move on to studying measures of angles and triangles, let's just review that there is 180 degrees in all triangle angles measures. Okay, so if there's 180 degrees in these triangles down here, we can find x very easily. We know that 120 plus 25 plus x equals 180. So we have 120 and 25, which is 145 plus x equals 180. Subtract this 145 from the 180. And we'll end up with x equals 35 degrees. Okay, on this triangle over here, this is an isosceles triangle. Notice that this side matches this side. That means this angle matches this angle. So we know right off the bat, right from the start, that y is 70. Now we just take 70 plus x at the top here equals 180 degrees. Well, this is 140 plus x equals 180. That means x is 40 degrees. And all I did there was subtract 140 from both sides. Okay? Okay, what I would like you to try is this triangle right here. If we know that angle is x, this angle is 110, and this angle is, let's say, 60, find the measure of x. And let's try this triangle here. That is a isosceles triangle with angle, let's say, B right there. This angle can be 65, And let's make this angle A up top. So find the measures of A and B in this one and X in this one. And I will see you in class.